Hi, so I'm going to be going over question 2, Java catastrophe. So this question asks us to essentially write compiler error, runtime error, okay, or whatever the line prints with respect to each line, right? So we'll be going line by line and checking what happens when we run that line. So this is split up into 2 sections. We have this very first section where we declare and instantiate all of our variables, and then down here, we'll have all of our method calls. So DMS, dynamic method selection, is going to be really helpful for this problem. Great, let's go ahead and start. So in order to ensure that all of our instantiations are valid, we have to use the is-a relationship, where we go from the dynamic type to the static type and ask, is the dynamic type a static type, right? So is cat a cat? In this case, all cats are cats, so we're okay here. Now let's look at this next one. It's a little bit more interesting. So is a Siamese a cat, right? So let's go ahead and look. Siamese extends cats. So all Siamese will be cats, right? So this is also okay. This next one, we're asking, are all cats going to be calicos, or is a cat a calico? Well, cat does not extend calico, so this doesn't look like it's going to work, right? Although calico extends cats, that doesn't necessarily mean that all cats will be instances of calico. So this will give us a compiler error. Now, this next one, we have is a calico a calico? This one's okay. Now, another interesting one. Is a Siamese a calico? Well, let's go ahead and look at the class structure we have over here. The class structure we have is both Siamese and calico inherit from cat. But that doesn't ensure anything with the relationship between Siamese and calico, other than that they both inherit from cat, right? So not all calicos will be Siameses, and not all Siameses will be calicos. These are neighboring classes. This is going to compile time error. Now this last one is a Siamese a Siamese. Yes, it is. So we're going to be okay. Great. So that was this first part. Let's just clear up some space. Great. Now let's look at the method call section. So we're going to say cliff.meow of Luna. Cliff's static type is going to be calico. So we're going to say calico.meow of Luna. Luna's type is Siamese. All right, we're looking at the static types for now. So let's look at calico.meow of Siamese. And look at that. We have something that matches exactly what we're asking for. We're looking in the static type of the method of the, oopsie. We're looking in, oh God. We're looking in the static type of the class invoking the method call. And we're looking for a parameter of type Siamese. And we found that. Now we're going to lock this in during compile time. Now let's look at Cliff's runtime type. Runtime type is the same, right? It's still going to be calico. So we're just going to go ahead during runtime, select the method that we locked in on during compile time. So we're going to go ahead and print meep. Cool. Oopsie. Now we're going to cast Cliff as a cat. So we're going to tell the compiler the static type of Cliff is going to be cat. And we're going to call .meow on Luna. Again, Luna is still Siamese. So let's see how this changes. Cat.meow of Siamese. So cat.meow, and we don't have something that takes in Siamese. However, cat is a parent of Siamese, right? Siamese is the parameter that we passed in. So this method is the closest thing that we have to Siamese available. So during compile time, we're going to go ahead and lock in this one. We have no other classes to look above for cat, right? Cat doesn't extend anything. So that's all we can really do during compile time. Now during runtime, Cliff's type, well, let's verify its type. Because we did a casting, we have to make sure that casting works itself out. It's casting over here, where we say its static type is going to be cat, and its dynamic type, according to over here, it's going to be calico. So we're going to say, is a calico a cat? Right? Calico extends cat. So yeah, we're okay. We can do this casting. This casting will work itself successfully. Now let's go ahead and look at the dynamic type of Cliff. So calico.meow Luna. So we're going to look in the class calico for a method that has the same signature that we locked in on during compile time. Do we have that? Well, we have meow Siamese. And after all, we are passing a parameter of type Siamese, aren't we? But that doesn't matter, right? During runtime, we're looking at a method that matches this exact method signature that we locked in on during compile time. It has to take in a cat, just like we specified. And this one does not do that. So we're going to go ahead and look in the parent of calico, and the parent is just cat, and that's the method that we locked in on during compile time. So we're going to go ahead and run the one that we have highlighted. This will result in a meow. Cool. Let's clear some space. Midori. Midori is a cat, and we're going to call cat.meow of Luna, where Luna is Siamese. Let's go ahead and look in cat. This is very similar to what we had earlier, where we looked in the class invoking the method call, which is going to be cat, and we're going to look for meow, and we're going to look for a parameter that's related to Siamese. Again, we don't have Siamese directly in our class, but we do have a parent of Siamese, which is going to be cat. So that works out. Let's go ahead and select this one. Now, Midori's runtime type is still going to be cat. So nothing really changes, right? We're going to look at during runtime. Do we have a method that matches the method signature that we locked in on during compile time? Well, yes, it's in fact the exact method that we locked in on. So we're going to go ahead and run this same method. Cool. Let's continue. So we have cat. We're casting once more. We already checked this cast earlier. This is going to be okay. So we're going to say cat.scratch of tofu. Tofu's static type is going to be cat, right, as seen over here. And so let's see if we can find a cat.scratch of cat. So in cat, do we have a scratch of cat? Yes, we do. Let's go ahead and lock in this exact method signature, right? This is a perfect match, so no need to look elsewhere. During runtime, Cliff's type will be calico. So now let's look in calico for the method signature that we locked in on during compile time, right? Tofu's type will also change. Let's just, for clarity's sake, do that. Siamese. But that doesn't really matter because we just have to find some sort of method signature that we locked in on during compile time, right? So let's go ahead and look in calico and see if we have a scratch that matches the method signature that we locked in on. And we do have that, right? We have scratch that takes in catc, right? So we can do better. During runtime, we found a method that's more specific to the runtime type of the invoking class, a class that's invoking the method call. Invoking just means this class on the left-hand side of the dot. It's the one that's doing the calling. So we're going to go ahead and run that method that we did better with. So regular scratch. Great, we're making good progress. Let's look at this next one. in this next one, we're saying cat.scratch of tofu. Now, let's go ahead and look at the method of scratch in cat. In order to call it from the method or from the class name, right? Just like we did cat.scratch, this method has to be static. It has to have the static keyword beforehand. If it doesn't, then we can't call it from the class name because it's not going to behave the same way for all classes. So if there's no static, then we're going to go ahead and run a compiler error. We cannot call this from the class name. Great. Let's go ahead and look at Midori. Midori's type is going to be cat.scratch of Cliff. Cliff's type is Calico. And let's do the process all over again. So cat.scratch of Calico, right? Yeah, cat.scratch of Calico. We don't have a direct match, right? So we're going to look at the parent of what we're passing in. We're passing in Calico. Calico extends cat, and look at that, we have cat right over here. So let's go ahead and lock in this method. It's the closest, most specific method that we have available. It's the closest to what we're calling it with, right? Oops, sorry, did not mean to erase that. There we go. So we're going to lock that in during compile time. During runtime, Midori's type is still going to be cat, and Cliff's type is still going to be Calico, so everything's good over here, right? We're just going to double down on this during runtime, right? During runtime, we're still looking in cat for the exact method signature that we locked in on. That's still the same. We're going to go ahead and run this method. Scratchy cat. Cool. So Midori.scratch of Calico and Tofu. So Midori's type is going to be cat. We're going to call .scratch on a casting of tofu, right? We're going to say tofu's static type is going to be Calico. So we're going to say cat.scratch of Calico. Let's go ahead and look. Cat.scratch of, well, we don't have Calico, but we do have cat, right? This is the same thing that we saw earlier. Let's go ahead and lock this in. Let's go ahead and see now during runtime if this casting will work. Now, instead of cat for its static type, we're going to say Calico. So is a Siamese a Calico? No, right? Earlier we saw this example over here where this was false, right? This is a compiler error. So again, we're going to error, but this time it's going to be a runtime error, right? Java trusted you during compile time to call some method passing in Calico as the static type of tofu. But unfortunately, during runtime, tofu's runtime type did not work with the is a relationship that we were looking for. So we're going to have a runtime error, right? So the method that we actually locked in on doesn't evaluate to anything, right? Because we had an error, we had a bad casting. Almost done. Let's do it. So we're going to say cliff.meow of Midori. So Cliff's type is going to be Calico dot meow of Midori. Midori's type is going to be cat. Let me just clear some space. All right, Cliff, which is going to be of static type Calico, dot meow of Midori, which is going to be of static type cat. We have this. Is Siamese a parent of cat? No, right? So we can't select this. What are we going to do now? We have no method that matches, right? So we're going to look in Calico's parent, cat, for a method that hopefully matches our method call, right? And here we actually do have something, right? We're passing in a cat, and we have meow passing in a cat over here. So we have a match. We're going to go ahead and lock this during compile time. Now, during runtime, the runtime type of Calico is, well, still Calico. Or the runtime type of Cliff is still going to be Calico, right? So during runtime, we're going to go ahead and look at Calico. And do we have a method here that matches the method signature that we locked in on during compile time? Right over here. I don't think so, right? There's nothing that really matches. So we're going to go ahead and look in the parent. And again, we are just going to call the same exact method that we locked in on during compile time. Cool. So this will result in, wait, what does that print? Meow. Last one. So tofu.scratch of Midori. So tofu's static type is going to be cat. Oop, cat. And Midori's static type is going to be cat. So we're looking for cat.scratch of cat. And would you look at that? We have an exact match. We're looking in the static type of cat, and we're going to call .scratch, and we have a parameter that takes in the same type as what we're passing in. Now we're going to go ahead and look at during runtime, where runtime tofu's type is going to be Siamese. So can we find in Siamese some sort of method that matches exactly what we locked in on during compile time? And would you look at that? We do, right? So during runtime, we can find a more specific method relating to the runtime type of tofu. So instead of calling the one that we locked in on during compile time, we're going to call the one that we found during runtime with the same method signature, of course. So that method is going to say, or print big scratch. And that's about it. Yeah, I hope that was helpful. If you struggled on this one and you want to brush up on your DMS, there's plenty of resources on the course website. There's a good long video that I also did, so feel free to search that up on Ed, or ask for it and we'll be happy to help you find it. Yeah.